Morning, scientist. Don't forget, watch this video completely for your daily participation points. Today we are going to start off by going over your stop to think answers from your Finding the Nerve reading that you did yesterday. So if you could go ahead and get that out and let's check it or correct it in Shobi. Your homework while we're on the screen is to read chapter 15, pages 449 to 452. That was attached to Tuesday's lesson. So the very first lesson this week, I attached all of this to that lesson. Your homework packet, page 2, is due Monday in Shobi, and that homework packet is also in the Tuesday's lesson, so everything is there. One thing I wanted to go over is on the Edpuzzle quiz, I noticed a lot of kids were getting this one question wrong about the order that an impulse travels. So my head's kind of covering this up right now. But if you would see here, it starts with the receptors. And these receptors could be in any of your senses. Your receptors start the impulse or the message. Your sensory neurons take it from your senses all the way to the interneurons, which are in your spinal cord and your brain. Your brain winds up interpreting what the response should be and hands off that message of what the response is going to be to the motor neurons. And if you can kind of think of the motor neurons as the ones responsible for the movement that happens in the reaction. So the motor neurons go to whatever muscle or gland that is going to make the reaction. Just wanted to clear that up. Okay. So let's look at your stop to think questions. So why are the nerves that take information from our world, your environment, why are they called sensory neurons? Well, it's because they are associated with each of your senses, like touch or sight. So they're taking the impulse from the senses to the brain to be interpreted. What kinds of information do sensory neurons detect? They detect information from all 5 senses. So any stimulus in your taste, touch, smelling, hearing, or sight. So somebody actually accidentally bumps into you into the hallway. What part of your body detects the feeling of being bumped? Well, whatever part of your body got bumped is where you would detect it. So your body is going to respond to that feeling or stimulus. Where is this analyzed? In your brain. C, inter means between. So why are the neurons in the spinal cord and brain called interneurons? Well, because they, in the relay race, they are in between the sensory neurons and the motor neurons. So they connect the sensory and motor neurons in the spinal cord, or they go between the sensory and motor neurons in the brain where the messages are analyzed or decoded and a response is decided on. Is breathing completely involuntary? Actually, breathing is not completely involuntary because I can not ache myself, make myself breathe faster or slower, but I don't have to think about breathing at all. I still breathe when I'm asleep or if I'm unconscious. Or so breathing is both voluntary and involuntary. Which body systems interact with the involuntary part of your nervous system? 2 examples and when these interactions might occur. So a great one that I'm sure you will remember is your digestive system. So your digestive system interacts with the involuntary part of your nervous system. So for example, you eat something, The muscles in your stomach move, remember, for that chemical digestion. And your stomach makes that acid to help digest the food. So that just happens involuntarily, automatically. Your muscles in your intestines move the food from your stomach through those intestines and prepare it to exit your body without you thinking about it or choosing to do anything. So that's also involuntary. So, when you decide what to wear in the morning, which of these three parts of the brain do you use? You would use your cerebrum because that's the part of the brain that's responsible for thinking and reasoning. What is the benefit of the cerebrum having folds and wrinkles? Well, think back to when we talked about the small intestine and the villi. Um, kind of being folded like that, and it increases the surface area. So that means there's room for more neurons than if the cerebrum was just smooth and didn't have those folds and wrinkles. The part of your brain that enables you to breathe even when you're sleeping is the brainstem. That controls all of the basic life functions, heart rate, breathing, blood pressure. So it is the brainstem that allows me to breathe when I sleep. All right, when your partner touched your hand, um, let me go back. Look at your hand. Where would you expect to have more touch receptors, on the palm or the back of the hand? I think I have more touch receptors on the palm of my hand because it seems to be more sensitive than the back of my hand. And I could test that by using the 2-point sensor that I made for the lab. Okay, when your partner touched you with the toothpick points in your lab, how did you sense that there was 1 or 2 points? Um, it says explain or draw the path through the nervous system that enabled you to tell whether it was 1 or 2. So, to explain it, when my partner touched my finger with the toothpicks, the sensory, or those touch receptors that were in my finger in the skin, sensed it, um, sensed that stimulus, and started a message, an impulse. That message or impulse traveled along the sensory neurons to my spinal cord and then was passed on to the interneurons in the brain. My brain analyzed the information, decided if that was 1 or 2, and then it sent a message through the motor neurons to tell my mouth and my tongue to say 1 or 2. If we were going to diagram it, so here, let's just say we have our sensory receptors here, and that was 1 or 2 points. Those receptors are going to start the stimulus, are going to start the message. It's going to hand it off to sensory neurons, and the sensory neurons are going to take that message through the spinal cord. And depending on what kind, if it was a reflex, it would just go from the spinal cord back through motor neurons. But this is one that's going to go to the brain through the sensory neurons. Sensory neurons are taking it all the way to the brain. You have interneurons in your brain, and your brain is going to analyze whether that was 1 or 2 points. Your brain is going to decode it, decide on a response. Those interneurons are going to pass that new response message to the motor neurons that are going to travel to the muscle that is going to make a response, or in your case, to your mouth that is saying 1 or 2. Here's another more simplified. Let's say the stimulus was you see a glass of water, and the receptors in your eyes are stimulated by the sight of that water. Those receptors in your eye are going to start the impulse. And once again, sensory neurons are going to take that impulse to the brain, to the interneurons in the brain. The brain is going to decode that message, decide what it is and what to do, what response to make. It's going to hand off the message from the interneurons to the motor neurons that is going to go to the muscle in your arms and hand to pick up that water for a drink. Okay. If you would now go to your nervous system homework packet, again, that is in the, should be a Notability. You should have put it there on Tuesday, but if not, it's attached to Tuesday's lesson. So the body senses are smell, taste, vision, hearing, and balance or touch. Homeostasis, we've talked about all year long. That's maintaining that life-maintaining conditions, that steady conditions that keep an organism's internal state steady no matter what's going on outside in the environment. A couple of vocab. I'm kind of covering that with my head. It says central nervous system. Central nervous system. And when we're talking about the central nervous system, we're basically talking about the brain and the spinal cord. We said that the nervous system was divided into two parts, the central nervous system and the peripheral nervous system. The peripheral nervous system are all the nerves that connect the brain and the spinal cord to all the other body parts. So the central is the brain and spinal cord, the peripheral, all the nerves. Neuron is just another word for the nerve cell. Synapse, synapse, that's the small space in which an impulse has to cross to get from one neuron to the next. And the word adjust means to arrange parts to make it work correctly. All right, so your homework is just to do page 2. Looks like this in your homework packet. That is due on Monday in Showbie by 10 a.m. And now for your reminder. Listen carefully.
Inspire you with a work of art. Dr. Len Matheson, a member here, just a scientist and a good friend. Dr. Len Matheson says that the adult brain has about 100 billion neurons, each with between 1,000 and 30,000 connections to other neurons. Now, if we stay with the minimum number of connections, we get to 100 trillion potential connections. If we start to talk about patterns and the combinations of patterns between those connections, we get to a number we can't even imagine. So he invented a word, Godzillion. It's like so much is beyond your wildest imagination. The number of neural connections in your brain. This starts to explain how your brain can work so fast. Recent estimates say that your brain performs 38,000 trillion operations per second. Do you have any idea how big a number that is? If you could tap your finger 10 times a second, do you know how long it would take you to get to that number? Over 120 million years. Now, if you're still with me, that means 38,000 trillion is a very large number. But it begins to explain something. You see, the simple point here is that your brain can handle that many operations per second, every second of your life. It keeps your lungs breathing. It keeps your heart beating. Keeps the blood flowing. It manages the temperature. It's like this coordination of impossible things. It's a symphony of life, really, is what it is. Breathing, living, smiling, laughing, crying, grieving, hearing, solving, dreaming, imagining. It's all coordinated in this thing, this brain that has a godzillion potential neural connections. That's the only way it happens. Now, when we see this, we're in awe of it, right? I mean, my British friends would say we're gobsmacked because we see these impossible, invisible systems coordinated together. I want you now to listen to an ancient poet king. His name is David. He describes his gobsmackedness even when he doesn't understand it scientifically. You knit me together in my mother's womb. I praise you because I am fearfully and wonderfully made.
My precious ones, you shaped me inside and out. You knitted me together in my mother's womb long before I took my first breath. Put your name in this psalm. I will offer you my grateful heart, for I am your unique creation filled with wonder and awe. You have approached even the smallest details with excellence. Your works, your design are wonderful. I carry this knowledge deep within my soul. You see all things. Nothing about me was hidden from you. I took shape in secret, carefully crafted in the heart of the earth before I was born from its womb. You see all things, even viruses. You saw me growing, changing in my mother's womb. Every detail of my life, every day, second of my life was already written in your book. You established the length of my life before I ever tasted the sweetness of it. My precious ones, you are fearfully and wonderfully made. Read Psalm 139. Rewrite it as your song because you are a miracle and God's got you. I miss you. I love you. I'm praying for you.